Welcome to our lesson on database management in Wise SCADA. When we click on the database area under Setup, we access the database management window. To use SQLite, which is selected as default, we need to save the project first. I saved the project with the named project. SQLite is a file-based database. It is quite lightweight and does not require any other installation to run on the computer. Now we need to select the database, but we haven't created one before. I am creating a new database named MyDB using the New button. Now let's look inside the created file. Our project's name is project. We see that our database file exists inside the folder named SQLite. We can move this file to another computer and access this database data there as well. SQLite is an ideal database management system for small projects that requires no installation and is extremely lightweight. However, it has a disadvantage. If multiple software access this database simultaneously, conflict issues may occur. Only one can add data to the database, while others can read the data. In larger projects where the database is used more intensively, you need to use one of the other databases. For example, MySQL is available. The username for MySQL on my computer is root, and the password is Fulk2005. Let's enter the information and connect to the server. Connection successful. Now, another database option is Microsoft SQL Server. When we check the local option, we will see the list of SQL Server instances installed on our computer here. This process may take about 10 to 15 seconds. Yes, 3 instances are installed on my computer. Let's select Wise SCADA. Since this is local, username and password are not required. However, if the database was installed requiring a password, you must enter your username and password. We connect to this one as well by pressing the Connect button. Now, when we click Load Database, we can see the databases previously saved on this database server. Let's select any one of these. We had previously connected to the server, now let's connect to the specific database we selected. This was also successful. We have established connections to both databases. We had already created SQLite. We can create this new database as well. With database clear, we can clear all rows and tables in the database. We can delete the database here with Delete. When we click the Check button, we can see the table structure, tag, and column lists of this database in the table below. Let's do this for each one. Each may have a different table structure. For example, table names in MySQL must start with a lowercase letter. One of the databases we configured must be the default. In the default database, SCADA will record data to the alarms and events tables upon various events. In other non-default databases, alarm and events tables are not used, but other tables you create will be used. You can select tags for these and ensure these tag values are recorded to this database. Let's create a few internal tags immediately. Let's name one of these tags Connected and the other Fault. Let's create one named Enable. We will use this later. Let's have a few standard tags whose types we can choose as we wish. Databases may not always be local, they can be remote databases. Even if local, in some cases such as corruption, it may not be possible to access the database. Therefore, the tag you select in the connected column will be true if the connection to the database and queries are successful. The tag you select in the fault section will be true if there is any error in the database connection or queries. Using these two tags, you can show the status of the database to the operator in runtime. Now let's explain how to add a column to the database. We selected the database. Let's add a column to the table. Let the column name be column 1. Then we select the data type and say OK. We have now added a column named column 1 into this database. When we make tags historical, we can add the columns related to those tags from here. Or when we click here, in the historical section of the tag, we can select the database and table. And give a specific name for the column or leave it with the tag name. We set the other one in the same way to be recorded to the same database and the same table with the tag's name. However, even if we say check here, we cannot see this yet. Because that column has not been created in this table yet. We could add it manually with add, but there is no need, it will be created automatically when runtime runs. Now we ran the runtime. The tags we selected were added to the table in the database. When we click the check button, we see in the window that appears that the table structure does not match the actual database and the details. We requested to process the database structure into the grid here by clicking the button on the far right. And we saw the tags created in runtime here. Now let's add another table named Table 2 to this database. This one also has two columns named ID and timestamp by default. Now let's save one of these tags to the other table, Table 2, as well. Since they are in different tables, tag names can be the same. And let's run the runtime. Now recording has been done to that table as well. Let's open the database again. By saying check table again, let's transfer the structure in the database to the table. As you can see, the tag is both here and there. Why might the value of a tag need to be added to two different tables? I am explaining that now. Data recording to the table is done at the time set by the recording period parameter. This table is configured as every second. We configured the second table as once a minute by writing 60,000. We also have row limit and day limit parameters. Row limit is used to limit the growth of the database size by cleaning old rows. When the number of rows in the database reaches the determined limit. Day limit is the day limit. For example, if we enter 365, it makes a year. This table will automatically delete records older than 1 year. Let's enter 3650 for the other table, which makes 10 years. This table will delete records older than 10 years. We recorded the same tag in one table every second, with 1 year retention, and in the other table once a minute, with 10-year retention. Our goal in all this configuration was to prevent the database size from growing excessively. If the database size grows too much, it will increase the computer's CPU and memory usage. Another recording method is the trigger method. Let's explain that here. We entered 0 for the period. It no longer records at a specific time-based period. If we don't select a trigger either, we cannot record to this database table in any way right now. Now let's select the trigger. Let's create a new Boolean tag for the trigger and name it trigger. Now I am selecting the trigger tag from here. When the trigger tag becomes true, it will make a record to the database. If we want to make a record on every change of the tag, we can add a second line. Select the trigger again, and configure it to record when it is false as well. Now, every time the value of the trigger tag changes, a row is recorded to this table. In parallel to this, we can also add a period. For example, I entered 60,000, once a minute. In this case, it records both when the trigger triggers and also records every minute. There is no limit to the number of databases you can use here. The limits on the number of tables and columns are related to the limits of the database management system, like SQL or MySQL, used, not Wise SCADA. For example, while SQL Server can have 1024 columns, MySQL can have 4096 columns. The historical package is not sold separately in Wise SCADA. Even the most basic model has unlimited historical capability. However, you may need to purchase separate licenses for databases like SQL Server and MySQL. For example, the unlicensed usage limit for SQL Server Express is 10 GB. If you are going to use a larger database, you must purchase an SQL Server license. Thank you for watching.